Hello everyone, my name is Anand Kayande. I am working in Veritas Software as a senior principal engineer. I am super excited to present this warfare against digital extortion using machine learning. The future of security and online safety is going to be decided by the ability of defender to predict potential attacks by developing machine learning techniques. Aim of this presentation is first to spread awareness of the criticality of ransomware attacks, how it happens, and secondly, how to safeguard your organizations using machine learning. Digital extortions happen through the ransomware attack. In this attack, a type of malicious software called as malware threatens to block access to data or computer system, usually by encrypting it, until the victim pays a ransom fee to the attacker. Ransomware attack or any attack on computer system of an organization is a game of hide and seek between the attacker and the defender. Every time defender builds better protection, attacker break it with superior attacks. For defender, the game is tough. For attacker to succeed, he needs to succeed only once, that too anywhere in the scattered system of organization. For defender to succeed, he needs to be succeeded every time, 24/7, that too everywhere. Protecting system is an endless job and it involves continuous learning. And so obviously way out is to build machines that learn themselves with the help of machine learning algorithms. Merely applying reactive tactics against ransomware will keep organizations running after extortionists. What is needed is a long-term strategy with continuous focus to win this war against ransomware. There is a need to have dedicated resources, planning, and funding to make security movement within the organization to protect system against digital extortions. Ransomware or malware or any other siblings are nothing but a piece of program that stays in your system for months and work without your knowledge in background and try to damage, steal, or log important information in your system. This presentation discusses important aspects of ransomware and easy ways of armoring for protection with machine learning algorithms. Typically, what is flow of ransomware attack? There are various phases and events that happens when actual ransomware attack happens in a system. These are a few common phases in the flow when system is under attack. First thing to happen is deployment of malicious program on the victim's machine. Attack begins with installation of components that are used to infect, encrypt, or lock the system. Deployment can happen through strategic web compromise, that is also called as waterhole attack. Here, attackers rely on strategic inspection of end users' machine and deploy malicious software accordingly. Drive-by download occurs when a system automatically downloads a piece of malware or spyware without the knowledge of end user. Another way attacker can deploy malware is through phishing emails. It is widespread and untargeted spam. It provides email attachment or links to malicious website. Vulnerabilities are there in almost all products. Attacker can exploit vulnerabilities in the software. Installation of malicious software follows the deployment. Once malicious content are delivered into victim system, the infection begins. It starts installing necessary components slowly on various nodes. Ransomware will use this initial installation to slowly spread throughout the affected network. It will be installing and reconstructing itself on number of systems and opening file shares. It will try for process evasion. It may now also run a series of scripts to ensure any native window protections are disabled, which could include turning off any protection features, turning off system recovery features, and finally, killing any anti-malware or anti-virus software and logging functions on the system. In a typical ransomware attack, once the malicious code is deployed and installed, it will begin to reach out to its command server, looking for instruction to control the victim's machine. Ransomware requires some form of communication channel to be established to ensure their communication occurs. The key that will be used to render the files on the system that is locked or encrypted is now active and ready for use by ransomware on the victim's device. All the files that have been identified by command and control process will begin to encrypt by ransomware. This could include anything from all of Microsoft Office document to JPG, GIFs, and any other number of files. Some variant not only encrypt the files, but also the file names, making it even more difficult for victim to know how far the attacker have gone and which files they have lost. Finally, the actual extortion. After the files are encrypted on the victim's machine, they tells how they have been compromised. Extortionists use number of methods to enforce payment. Some ransomware variant will allow you to decrypt one file for free to prove that they have the key to your system. Bitcoins and prepaid vouchers are commonly used payment methods. There are various forms of ransomware. Typically, ransomware are written in different programming languages, having different execution requirement and targeting different runtime environment. They are difficult to encode, as many times they are in binary forms and not in the human readable form. Also, many times they are obfuscated. It makes difficult to understand and read them. They can also be honey trapped inside Windows exe, DLL, or even popular applications like doc, PDF files, and their plugins. Now we know that ransomware attack is very dangerous and how critical it is. Then what is the remedy? Deep understanding of computers, network internals, along with active reverse engineering tool supported by machine learning algorithms can surely prevent ransomware. Machine learning can help with some of the problem caused by modern ransomware due to its pattern matching and prediction abilities and inbuilt nature of adaptiveness. During reverse engineering, we extract information about internals and working of a software. With reverse engineering binaries, we can understand functionality, purpose, and sometimes origin of the binary. With the combination of static and dynamic methods of reverse engineering of binaries, along with pattern matching algorithms, we can build a very effective and adaptive defensive system to guard against ransomware. Let us quickly go through these methods. One of the ways to stop ransomware attack is to perform structural analysis of binary files. Any binary file is a typically zipped archive file containing resources, metadata, executable code, and manifest file. We can unzip a binary file and see something like this. Manifest file can be starting point for analysis as it provides overview of entire application, such as requirement of permissions, overall structure, external references, dependencies, and so on. Binary files can be further decompiled or de-interpreted to get human readable code. All of these are tedious and laborious work to investigate each and every binary file in the system. Here, machine learning can actually help. We can develop machine learning algorithm that can look into sample set of data, and based on various parameters, it can predict if a binary file is a potential threat or not. Extracting feature is first important thing in structural analysis. There can be many parameters that can help to decide if a binary file is a threat or not. Just for an example, we can look for this parameter. Look for what all access of resources and services a binary file is looking for, like camera, microphone, files, printer, network, registry, and so on. For example, if an application that is supposed to be used for spell check is asking for access to microphone or registry, then it may be potential threat. System need to know based on training data that application needs with resource access. Then origin and creators. Look for application certificate, authorship information. Training data with various authors and origins can help to predict potential risk. Then dependency. Look for network dependency or any other port it opens to contact outside servers. For example, it would be unreasonable to have a network dependency for an application that is used for drawing a picture. Limitation of this approach is that it won't work if binary file is encrypted. Static analysis of code is a study of application without running that. Using reverse engineering tools to get the binary code into human readable code, and then look for potentially dangerous code, like code for locking files, code for opening port to outside servers, high-risk system calls, and so on. Get training data, extract features like this to predict if code is potential threat or not based on static analysis. So typically what we can look is hard-coded IP addresses for command and control server, linked to external downloadable payloads, asking for administrative permissions, socket services, registry, browser history, and so on. In addition to structural and static analysis, there is huge potential to perform runtime analysis of program. We need to run application on sandbox. The most obvious execution side effect to look for when analyzing a malware is its network behavior, resource utilization, and so on. These are just examples, but there are many things that we can look. Many malicious applications require some form of external communication to receive instruction from a command and control server to share stolen data or to share some unwanted content. By observing an application's runtime network behavior, we can get a glimpse into some of these communications and generate a rough signature of the application. Besides network profiling, there are few more things that machine learning can help for behavioral analysis of binary files. Like look for system calls, then the sequence of operation, then all the operation and with logically what they are looking for during the execution that can help to classify or identify the ransomware. Then look for flow of combined activities, like for example, accessing a file followed by suspicious system calls, followed by opening a network port. Typically, we perform ransomware predictions on a system where we have full control over its runtime environment. Dynamic instrumentation is another powerful technique for modifying the applications or its runtime environment or runtime behavior by hooking into a running process and injecting some custom logic into a running application. We can add code dynamically before typical potential malicious code like locking of files or accessing outside network or print variable state and so on. We can prevent code or make conditional execution by adding extra lines of code into already running application. So that is something called as the dynamic instrumentation. These and there are many other machine learning techniques that can really make computer security adaptive. In coming times, I won't be surprised if I see more and more machine learning techniques helping us to make our system calls more secure. With that, let me stop here. I will be more than happy to discuss this further. And with interested folks, I will like to take questions, comments, and suggestions. Thank you.